Hi, this is Mr. Max. Yesterday I did the um, paper two of ERONGO region for grade 11s. I did paper two. So this is one of the questions there that I have left out. It's a question on construction. Now, what I'm going to do here is just to show you how you should approach that question. Um, Within this. So if I were to measure with my instruments, um, it's not going to be exactly the case, but I had the paper in front of me, so I already measured this, and I'm just going to show you the steps and where the shading should have taken place. Now, this scale is very important here, that 1 centimeters on this map represents 20 kilometers, and it will be important, especially if you have to draw, like this B Roman 2, you have to draw the locus of points, which is 70 kilometers from N, and we need to change this 70 kilometers then to centimeters using that scale. But let's take it from the top. So by making appropriate measurements, find the distance in kilometers of H from N. So your measurement will be you grabbing a ruler, and what you will do is that you are going to be measuring, the points. I'm just taking my ruler around here, and so my measurement is inside here, but it's going to be something that you are going to measure like so. So maybe I should just start it off at 0. So let's just start it off at 0, and you're going to measure, and whatever you're going to get, that will be the distance that is over there. So in fact, um, if you were to measure that, if you had a paper in front of you, you would notice that that distance is exactly 4.5 centimeters. Now, in order for me to change it to kilometers, I'll have to multiply that by the scale. All right, because if I know 4.5 centimeters, what would that be in kilometers? If I know I have that, then obviously it implies that I must multiply this in order to change this. Right. So in a nutshell, this would then be 90 kilometers, give or take. That is that answer to that question. Okay. Then they say the bearing of camp N from H. You're supposed to find the bearing of N from H. So we are going to go to H. So first of all, let me just connect the two by drawing perhaps a straight line. Okay, so let me just grab and then say I'm going to take a line, I'm going to connect that line here. So what it is that we need to do is we need to find the bearing by measuring this whole angle over here. Okay, if it says find the bearing of N from H, we need to go to H, then we go in a clockwise direction. So you'd be grabbing your protractor, and you would be measuring. I'm just going to change or rotate my protractor. Okay, so I can have it exactly at that point. So I know the angle is bigger than 90 degrees, so this is what I'm going to use. And you should have a look over here to see what that angle should be. So I'm getting an angle of 159, 160, give or take, right? Okay, so there's nothing wrong then if you were to mark this for you to say, wait a minute, anything between, because it all depends on how accurate the students are, because this point is quite big, the diameter over here. So to find that exact point over there is the issue. So you should actually mark something within a range, and an acceptable range for me, for example, will be maybe anything from 159, and then I'll add plus minus 1 degree to that. Okay, so 159 degrees, it's already a 3 figure, so plus minus 1 degree. So if a student were having the paper in front of them and they get 160, 158, yeah, that should be acceptable as well. Okay, let's just move the instruments to the side. It is intended to build an airfield which is closer to O than H, not more than 70 kilometers from N. So they are now dividing it into sort of three little pieces. First part, they say use a straight edge like a ruler and compass. Construct a locus of points which are equidistant from H and O. Now, when they ask you to do that, so I'm going to join. Let me take. I'm just going to join point H and point O. Now, the locus of point that are equidistant from that means we are going to find the perpendicular bisector. So I'm going to bring my compass, and what you do is you place your compass in one end and you open your compass slightly more than half the distance of that line, and you can just eyeball it, so to speak. Okay, so I'm just gonna do that, and perhaps um, this is basically what you'll see that I'm going to do. And I'm going to take that same point and I'm just going to bring it to the other side. Okay, that same point to the other side. Let me just see. So what I will do over here now is I'm going to then just draw that. Okay, so that is going to be the bisector. So take your ruler and then join those points. All right, so you can take the ruler. I'm just gonna turn it around so it is it's a little bit technical, but if you have your instruments right in front of you, it should definitely be much easier. Let's move it a little bit to the side. Okay, so we are going to draw this line over here. So there we go. So that's the perpendicular bisector. So every point from this line is exactly equidistant from H as well as from O. So that took care of the first part, which is 2 marks. Then they say, draw the locus of point which are 70 kilometers from N. So inside the farm. So what that is you're going to draw not a complete circle, but like a major arc with a radius, and that's where it comes in handy. Okay, so let me just do the working over here. If 1 centimeter is 20 kilometers, then 70 kilometers, if you have to convert it to centimeter, will require you to divide, and then you get about 3.5 centimeters. So you're now going to take your compass and you are going to open a radius of 3.5 centimeters. Now I'm just, again, as I said, I'm just eyeballing it for the sake of this. So let's say that is going to be 3.5 centimeters. All right. The way that it would appear, right? The way that it would appear. So perhaps I can choose, I don't know, another color. Then it would be, oopsie daisy. So let's just undo that. My goodness. Let's take this red, maybe. Better yet, even the green. Okay. So this is all the way. They say inside the game farm. So that's a radius of 3.5. That's what you do. Right. So from N, any point there is 3.5. Now they say shade the region in the diagram which represent the possible location of the field. Right. We know that it is closer to O than it is to N, and it's within. It's not more than 70, so it cannot be over there. So the place that you are going to shade, our shading, is this region over here. This is the region that we were and you are supposed to shade. Right, so that is how your shading should be. Of course, remember from N, you have 3.5 centimeters as you work it out. And basically that's how, this particular question is going to be. I had to do it separately so that you can get an idea more or less how the shading should be and how you should interpret this question per se. Okay.